Welcome to today's Explainer. I am absolutely thrilled you're tuning in because, wow, we are about to unpack a completely mind-bending paradigm shift. Seriously, we're diving into a revolutionary framework that is going to completely redefine how we view the human mind, our society, and honestly, the very fabric of reality itself. Get ready because we're about to challenge practically everything you thought you knew about how the world works. Here is a quick look at the roadmap for today. We're going to start with the limits of classical science, then dive right into what this quantum turn actually is. After that, we'll look at the mathematical proof behind our so-called irrationality, explore how observers co-create the world, and finally, chart the path to unifying all this knowledge. All right, let's jump right into section 1, the limits of classical science. For centuries, right, modern science has basically operated on this highly deterministic classical worldview. You can picture it like a giant ticking mechanical clock. And look, this approach was absolutely fantastic at breaking things down into neat little independent parts, finding clear cause and effect relationships, and treating the world as a predictable machine. But here is the massive problem. This framework completely falls apart when you try to capture the multi-layered, contradictory, and sometimes downright absurd nature of human existence and human cognition. It just doesn't fit. So this naturally brings us to a really critical question. Are human minds just faulty computers? Because traditional cognitive science basically treated our brains like standard information processors. But when you look at things like the frame problem, our inability to program computers to just know what context matters, or the sheer complexities of having a physical body, this classical model completely falls short. It treats human unpredictability as a statistical error, like a glitch in the machine. But what if those aren't glitches at all? What if our complex, totally context-dependent judgments are actually features of a much more sophisticated system? Okay, moving on to section 2. What exactly is the quantum turn? Let's break this down. In classical probability, events are assumed to be superlinear, independent, and commutative. Commutative is really just a math term meaning the order in which things happen doesn't fundamentally change the end result. But when we shift gears to non-commutative probability, which is the absolute engine of this quantum turn, literally everything changes. In this new framework, events are deeply interconnected, possibilities overlap, and crucially, context and order matter entirely. By shifting to this mathematical lens, we finally have a language to describe human complexity without forcing it into rigid, black and white boxes. Now, hold on. Before we go any further, I need to give a huge disclaimer here. We are talking about quantum-like modeling, or QLM. We are absolutely not saying there are literal quantum physics particles buzzing around inside your brain dictating your choices, okay? This is an epistemic extension. We are simply borrowing the highly advanced mathematics of quantum theory, specifically that non-commutative probability we just talked about, to describe macro-scale biological, social, and psychological systems. It's a totally brand new cognitive frame for the humanities. Which brings us to section 3, the mathematical proof of irrationality. Now, what's really interesting about this slide is something called the question order effect. You've probably experienced this yourself, right? If someone asks you question A and then question B, you might actually give a totally different answer than if they flipped it and asked question B, then question A. Classical statistics looks at that and calls it a bug, or says humans are just being irrational. But researcher Masanado Ozawa applied a quantum measurement framework called instrument theory to this exact problem. And guess what? He proved that this behavior is mathematically consistent and perfectly rational when you use non-commutative probability. It proves that human context dependence isn't an error at all. It's a measurable mathematical state. Building directly on that idea, researcher Hayato Saigo proposes that human cognition doesn't work via a simple input-process-output machine. Instead, it follows this fascinating three-step quantum-like structure. Step 1 is the state. Your mind basically holds a superposition of potential, meaning multiple overlapping possibilities exist all at once. Step 2 is the effect. A specific question or context forces an observation. And step 3 is transformation. The very act of observing actually changes the meaning of the state. Your mind isn't a calculator, folks. It's a highly structured, incredibly context-dependent realm of overlapping possibilities. Let's pivot to section 4, the co-creation of the observer and the world. And this brilliantly illustrates a concept known as agentival realism. See, back in classical science, the observer and the object being observed were kept totally separate. You're supposedly just passively watching the world happen from the sidelines. But the quantum turn argues that our bodies are dynamic devices that actively co-create reality. The very act of observing or interacting with the world is what actually generates the phenomenon. The subject and the object are deeply, fundamentally entangled. The sheer breadth of this framework is just staggering. Take anthropology, for instance. Fieldwork is being completely redefined. It's no longer about passive observation, it's the active co-creation of culture. Over in art, researchers are measuring how ambiguous, overlapping meanings act as a literal quantum superposition right inside the viewer's mind. Clinically, we're exploring things like negative capability, which is our ability to just sit peacefully with uncertainty using models like the quantum Zeno effect. And in history, biological evolution is being reframed not as some fixed destiny, but as an interference of overlapping possibilities. We are literally turning abstract philosophy into incredibly tangible analysis. Finally, we arrive at Section 5, the path to unified knowledge. So where is all this heading? Well, the answer actually lies in technology. Researcher Haruki Amori introduces this incredible concept of quantum falsifiability. Because we are using the math of quantum mechanics to map human behavior, we can actually use real-world quantum computers to simulate these complex non-commutative theories natively. We don't even need to wait for some massive future supercomputer. Current, small-scale quantum computers can act right now as simulators for human cognition, turning the humanities from purely descriptive interpretations into a rigorous predictive science. That is a real game changer. So the absolute crucial point here is this. For literally generations, we've had this massive, towering wall between the natural sciences, which dealt in hard, objective facts, and the humanities, which dealt in subjective human meaning. The quantum turn finally provides a shared mathematical language to bridge that historical divide, fundamentally transforming both the humanities and natural sciences from the inside out. Wow, we have covered a massive shift today. We've moved far away from viewing humans as rigid, faulty machines, and instead we are recognizing ourselves as dynamic participants, mathematically generating reality with every single context-dependent choice we make. So I want to leave you with this final provocative thought to chew on. If your life history is not some fixed, predetermined destiny, but an active, continuous generation of reality, how does viewing your own choices as an overlapping of possibilities completely change your view of the future? Thank you so much for exploring this deeply fascinating topic with me. Keep questioning, keep learning, and I'll catch you in the next explainer.